Hi there, I'm James, and welcome back to Hypertops, where we push the limits of materials and machining in the pursuit of the perfect spinning top. Today we're going to look at what makes Mk.23 my new longest spinning top. This video wouldn't have been possible without our first sponsor, JLC CNC. More on them later. Let's get right into the technical changes. I made a few modifications with this design, most noticeably with a spindle. Our last model, Mk.22, had a core and spindle made from one solid piece of aluminium, which was good for concentricity and ease of machining, but very wasteful and resulted in delicate stems. This photo shows a quasar top which failed catastrophically just as I was finishing it. This was definitely something I wanted to avoid. So, taking inspiration from Iacopo Simonelli, I split it into three pieces: an aluminium core and grip, separated by a titanium rod. I chose titanium for its excellent torsional rigidity and low density. This allowed for a spindle only 2 mm thick and weighing just over a gram. I also made the spindle longer to make starting the top easier. This is because a missed twirl with a shorter stem results in a larger angle change of the flywheel than with a longer stem. Because of this, longer stems are a bit more forgiving. The next change is less visible and involves the core. This is the underside of Mk.22, and this is Mk.23. As you can see, the bottom of Mk.23 has a continuous curve, which allows air to flow seamlessly from the tip, over the edge and off the flywheel. I did this with the hopes that the reduction in turbulent air under the top would make it more aerodynamic. But you may be concerned about all the useless mass here, and so was I, so I decided to make it hollow. In fact, the top and bottom walls of the core are just over a millimeter thick, making this core configuration even lighter than Mk.22's. The problem with this is that with my old machining method, it would be impossible to make. The hollow region would be covered by the flywheel. So, to solve this issue, for the first time, I used CNC machining. Actually, our sponsor, JLC CNC, machined this part. Their service is simple and convenient, especially for designers who need quick and inexpensive, high-quality prototypes. The process was as easy as uploading a CAD file, selecting materials and tolerances, and placing an order. In just 1 week, I received a carefully packaged parcel with accurate parts inside. JLC CNC is one of the most popular manufacturers in China, offering world-class equipment and highly competitive prices. If you're looking for affordable, high-quality manufacturing services, JLC CNC is a great choice for your next project. With this part, all I had to do was attach the flywheel and do some polishing, and the core was done. Fitting nicely into this new core is the last major change, the tip. Instead of high-speed steel, I used tungsten carbide. It's an even harder material, which allows for a smaller contact point and hence less tip friction. The downside is that being so hard, after a few runs it drills microscopic holes into the base, which would be detrimental to future spins. Still, for the longest possible single spin, carbide is great. Going forwards, I have a crazy plan to solve this base issue and further optimize the contact point, but this is still a work in progress and will have to wait for another video. With all these changes, Mk.23 performed incredibly well. On the very first spin, it went for a crazy 1 hour, 14 minutes and 53 seconds, beating Quasar 1 for the world record. Unfortunately, I didn't film this test spin, and the next 3 attempts all lasted for just 1 hour and 9 minutes. So this is what you'll see in the full spin video for Mk.23, which is coming soon. However, I'm not too concerned about missing this record spin, because I recorded the RPM decay every 10 minutes, so I still have some data. Doing some extrapolation and comparing this to what I measured during the 1 hour and 9 minute spin, we can see the average efficiency was slightly higher throughout, which suggests the surface finish and tip sharpness were marginally better. I'm still really happy with the hour and 9 minute run. In fact, the efficiency is knocking on the door of 97% for the vast majority of the spin. This is the best I've ever measured. And yet, there is certainly room for improvement. First is the flywheel. Since I only had the flywheel to hold on to with the lathe chuck, I didn't get the chance to machine or polish its outside. Second is the grip. Sharp eyes may spot that the grip isn't quite concentric. More so, the geometry and quality of knurling isn't quite what I'd like it to be, and as a result, I really struggled to get Mk.23 started over 2000 RPM. I'm keen to fix these issues with Mk.24, which I'll be working on when this video comes out. If you enjoy my videos and haven't yet, then please hit like and subscribe below. We're about to hit 5,000 subscribers, which is very exciting. If you have any thoughts about Mk.23 or suggestions for Mk.24, then do leave them in the comments below. I always enjoy reading them. That's all for now. Thanks for watching.